So just as background, I got involved in IPv6 in about 1999 in helping to make a embedded IPv6 stack for basic feature phones for 2G GPRS phones. Since then, I've been involved in Nokia Research Center, where we made the first implementation of IPv6 for smartphones in Symbian. And last few years, I've been in our Linux product groups and have been working on IPv6, among other things. And also been involved in a lot of trials in 2003. We did a mobile IPv6 trial in 2005 with Telia Sonera in Finland. A number of trials with Vodafone, but most of those trials all have been like sort of in R&D groups and not anywhere near production. Usually a lot of times those trials had to be segmented off of the production networks because none of the operative groups wanted IPv6 on the networks. So that has been one thing that we've done a tremendous number of trials. Got to see packet flow, got to see video running over IPv6, got to see the dancing turtle, but not a lot else. And I've also been very involved in ITF. I've been the main author for the IPv6 node requirements in IPv6, basically defining what the minimum set of IPv6 standards you need to support in an IPv6 node, and about 15 or so other RFCs in the ITF. So I've been doing a lot in IPv6. So I'm just also going to comment that I'm really surprised that so many people stayed around. I figured that I was going to be the last person on stage today and that a lot of people would try to beat the traffic, so I really appreciate it. So I'll try to keep this interesting, and hopefully you guys will have questions or want to know more, so feel free just to ask. So basically, I want to go through what are some of the motivations for why did a lot of cellular groups push to have IPv6 in mobile networks? What are some of the main deployment options in the mobile networks? What's happening in the handset and application space? What about network space and deployments in operator space? What are some of the sort of key challenges? What are some of the key work areas, and where are we currently seeing things that really need more work on? And then just some practical advice. One of the things that has happened is the mobile networks are really actually kind of complicated, because right now you can think that you have application makers, OS providers, handset makers, you've got the operator networks, you've got the core networks, you have the transit network, you have the operator services, which generally tend to be within an operator service, which is segmented from the outside. So for example, if carrier A has a number of services, most likely those are only available to the subscribers in that network, and they generally have been built up in a private addressing scheme. So, let's say that the MMS servers for AT&T, those are generally using private IPv4 addresses, because those are not meant to be accessed directly by subscribers outside of that domain, et cetera, so that the IPv4 addressing in mobile networks is very interesting, because it's generally done kind of in an analogous way as a intranet. But generally, nowadays, most of the mobile, or not most, but a lot of mobile devices are internet enabled, and they are increasingly becoming more and more popular. The ITUT estimated that there's about 5.3 billion mobile subscribers right now, and that basically is, some people will have multiple phone numbers or mobile numbers, so that's collectively the number, if you figure some might be repeated. And there's becoming more and more of a trend for always-on applications. So you want to get your Facebook updates, you want to get your email, you want to stream music, you want to have Spotify on the device, etc. One of the things, though, that has been happening is that traditionally mobile phones were built and designed to save power in a way that use of mobile phones was bursty. You'd have a 10, 15-minute call, you'd put the phone in your pocket, and the phone would sort of be silent for, until you got your next phone call or your next SMS. So they were meant to go into a deep power sleep stage. When we have these always-on connections, actually the phones generally tend not to go into as deep of a sleep state if they're always fetching updates, et cetera. So that has sort of caused a lot of issues with power management on mobile devices. And I think, if you look at any smartphones, generally you're lucky to get a day use out of them without having to charge it. And I know a lot of people, if they know they're going to be away from a power source, will turn off all of the internet communications, turn off the IPv6, or excuse me, IP stack or any GPRS connections because they want to save power. And that goes to show you right away that's going to be a major part of where people are spending, where your power budgets are on a mobile phone. It's happening with internet communication. And a couple of other things that are happening is that that 4G networks are rolling out. LTE is coming out. LTE is a packet-only network, and most of the carriers want to move to having voice over LTE and start to ramp down their circuit switch network. Circuit switches, which are where you're running your voice calls and your SMSs right now. And if you as a network provider have to have a circuit switch network and an IP network, your OpEx and CapEx costs are going to be more. So a lot of carriers do want to ultimately run everything over IP and be able to start to decommissioning some of the 2G networks. So there's more motivation to sort of move to IP connectivity there. Another thing is people have been talking about NAT 444 or carrier-grade NATs. There's been a lot of different vendors, and I don't want to pick on any vendors, but there are some really serious scalability questions about carrier-grade nets. If you go to something like the first hop router SGSNs, some of them can serve 10 million users. So if you have to have 10 million connections on a carrier-grade NAT, that might not scale very well. And ultimately, IPv4 is a very scarce resource going forward. So you can start to be, some scenarios do have carrier-grade NATs, but I think that's something that you don't want to depend upon for your long-term subscriber base. So in the next slide, basically, one of the things which, when we were doing some research on this case a few years ago, when we were looking at how IP connectivity was affecting power management on a device, we found that with some services, when a phone would be given a private address by a carrier, that we would see significantly worse power behavior on it, that the battery would run out much faster. And part of that is because generally NATs, you need to refresh the NAT bindings over time. Otherwise, the NATs go and do garbage collection and reassign IP addresses. And since NATs are sort of transparent middle boxes, you don't know that they're in the network. You simply have to continuously be pinging the NAT to keep the NAT bindings alive so that the connections go. Because if you lose the connection, essentially then the device behind the NAT disappears from the outside network. So we found that a lot of carriers who wanted to have connections which were coming inbound to the mobile phone needed to have the phone refresh the NAT bindings. And that prevented the phone from ever going into deep sleep mode because generally NAT bindings can run on an average of 30 seconds to a couple of minutes in terms of their refresh time. And if your phone has to continuously be sending packets every 45 seconds, it will really drain the battery quite significantly. An easy thing to do nowadays is that if you go to whatsmyipaddress.com on your mobile phone, you'll start to notice a lot of your connections will actually have a public IPv4 address, and that's part of the reason that they are having a public IPv4 address, because then it does make the phone last longer. It's in a carrier's interest, obviously, to keep the phone from running out of charge, because if your phone goes asleep or runs out of charge, you're going to be an unhappy user, and you're probably not going to make calls and generate revenue. But ultimately, at the end of the day, IPv4 public addresses are running out, and carriers are trying to figure out how to go forward and what to do to make that happen. So just generally, we should all know basically how private addressing works, but if you're behind a server and you have a NAT in between it, and you have a private address, if the NAT binding runs out, then the server on the outside will not know what device or what address is assigned to that device. We also found very early in the stage that some carriers were trying to reclaim private addresses too quickly, and they actually misdelivered content into mobile phones, because let's say that it was 10.1.1.1, and they timed out the binding, and another device came on and got that address. That new device was getting packets for the old phone, and again, that was something that was also seen as really problematic. So that has been one of the main things, or part of the reason why 3GPP, one of the standards bodies behind a lot of the third generation and LTE networks, wanted to aggressively move to IPv6. Their first plan was to go to IPv6 only addresses to get over that. But again, when these carriers started try to discuss to the operative units, okay, how do we deploy this stuff? All of the operational teams have said, hey, this isn't ready yet. We're just trying to get the 3G network running. We all know that even here in the US, 3G coverage, not to mention LTE coverage, is very spotty. A lot of the carriers have had a lot of issues in terms of network capacity, and there's been a lot of challenges in just getting, let's say, basic 3G connection, so that a lot of carriers have been trialing on their internal networks, IPv6, but have not been really willing to get that in their live networks. Generally, today, I think we found, and yesterday, we heard a lot about what you would need to do for an IPv6 trial, various checklists, other things to do. Obviously, you need to have IPv6 routers and switches. You need a transit provider. You need to have your peering in place. You need to have hosts. You need to have apps. I haven't heard a lot of people talk about apps, and apps are always a little bit more interesting. Some of the apps you think should work and should work well, but not all of the apps actually have the right behavior for handling IPv6, handling IPv6 literals. A lot of apps still are using hard-coded IPv4 addresses, et cetera. And there's something I'm going to talk about in a little bit about some things which people are trying to do to overcome some of the challenges of running a dual stack. But especially in mobile, that's another issue, because on your mobile phone, who's got a terminal that you can go and do trace route, run ping? So generally, the configurability and the management of IP connections on your mobile phone is a lot harder than what it would be on your laptop. So again, getting the connectivity right, getting it simple, so for the end user it just works, is something that's important. A lot of the carriers are also afraid to have anything which is going to increase their customer care costs. If you're trying to browse Facebook and it doesn't work, you're going to call up the customer care and they're going to ask, what's your IPv6 address, or are you using IPv4? I don't think that you're going to get very far with helping users if they have to do that from a mobile phone. So again, they're being really cautious in that area. How to handle address planning, address configuration in DNS, and there's a lot of issues with that I'll talk about in a little bit. Transition mechanisms, unfortunately, I've got internal information that I'm not allowed to show because it's under NDA, but I would say that most of the carriers are using different plans. Some of them want to do IPv6 only. Some want to do carrier grade NAT. Some want to do dual stack, but some are using tunneling. So still, there's not been a really good consolidation on what kind of transition mechanisms to do. Most likely, you don't want to have transition mechanisms that come all the way out to the mobile phone, because the mobile phone is going to be battery limited and going to be power limited, and people also pay for packets that they transmit. So if you're going to do tunneling, that's going to give you more packet overhead, and if you have to do more processing on the phone, obviously that's going to affect your power management and your CPU. So again, a lot of carriers have been trying to push some of the transition mechanisms out to the network. And again, middle box support, firewalls, proxies, et cetera, that's still somewhat of an open issue on mobile networks. That is probably not as well established as it is sort of in enterprise networks. So the main deployments that have been being discussed in mobile networks are dual stack approach, and that seems to be the most friendly for the customer because you run IPv6 or IPv4 from the mobile handset. The handset doesn't really have to do anything. It speaks both, and it should just work. It seems to be pretty much the standard way to handle transition in 3GPP, and that's been specified. I'll talk about some of the specifications in a minute. Some people are talking about doing IPv6 only and doing some transition mechanisms and some protocol translation in the network, but protocol translation is not always very pretty and elegant, so, and also scaling up to the large number of mobile users that are going to be behind such a translator is also could be an issue. One thing that I would also say I didn't put on here is, though, that if you're going to be doing a trial, one of the things is to try to think opportunistically. Can you start to bring out some services that are going to be running IPv6? Most handsets that are going to be starting to deploy IPv6 will be dual stack. So you could run IPv4 for the services that need IPv4, and then you could run IPv6 for the services for IPv6. And if you build some intelligence in your network, you'll be able to manage that a little bit better. Generally, we've had a lot of interesting successes with trials that I've been involved in, where you sort of don't try to do IPv6 for everything, but you start to enable some things where that you can measure, you can get good experience with, and with new services, so that then you look at how to go service by service for different things with IPv6. Previously, not to get in too much detail, but the way that most of the data connections work through the cellular network on your phone is through something that's called PDB contexts. They're really similar to something, to PPP links. They're very much modeled after dial-up because obviously that's what carriers are used to, dial-up. So the PDP contexts were initially of two flavors. You could have one which was IPv6 only, and the second which was IPv4 only. And the mobile phone was expected that you could run different PDP contexts. So when you go and send an MMS, you have one PDP context. When you browse the internet, you have a second PDP context. And if you have an operator like service for video call or something like that, you might have a different PDP context. So that, in a way, mobile phones have been able to be multi-homed, but that's a little bit of just a quirk on how the carriers ran the networks. In 3GPP Release 8, which is where LTE started to be specified, we now have a new PDP context that does both V4 and V6. So that makes life a lot easier. It means that basically you can have a full dual stack approach from the handset and connect for IPv4 services over IPv4 and IPv6 services over IPv6. So that generally works pretty well. And that allows to handle fallback scenarios. So if you're running IPv6, but for some reason there's a failure because of IPv6, something's not enabled, or the service you're trying to get does not have an IPv6 address, or is not reachable by IPv6, you can fall back to IPv4, and that works out pretty well. But the other thing is some of the carriers are talking about IPv6 only, but one of the challenges with IPv6 only, and this is something that we really found in a lot of ways, is that everything, including applications, must be IPv6 enabled. Otherwise, so you might need a solution like NAT4.6 on the host, and that's sort of not very nice to put a NAT actually on the device. We've actually worked with Google, and on a previous phone, we did a NAT4.6 app on the phone, and it worked, and it ran beautifully, and we had really good compatibility, but really crappy battery life. So you're trading one ill for another ill. IPv6 is not always available, and I think we want to get to IPv6 only, but I don't think we can depend upon it. I think most of the people today have been talking about, IPv4 is here for the foreseeable future. So thinking that we do IPv6 only is probably unreasonable right now. So one of the impacts that really, when you see trying to do something in mobile, you start really getting into a lot of challenges, because IPv6 does impact all levels. So basically, when you download an app from the App Store, hopefully the app is able to use IP sockets correctly. It's not depending upon literals. It understands IPv6 packets, etc. That's not always reasonable to assume. The services and content providers, they also need to support IPv6, obviously. APIs need to have IPv6 support. In my company, we've had some challenges where we've moved to a new library of, let's say, programming library and middleware that didn't have IPv6 or had something broken in terms of how it handled DNS queries or something else. And so then the apps could be IPv6 supporting, and the device could support IPv6, but there was some middleware component that just broke everything, or the programming libraries had some assumptions that didn't work, and that got ugly. Obviously, you have to have the TCP/IP stack on the phone that supports IPv6. And then the other thing is that the modem has to support IPv6. A lot of the phones that are out there are supporting IPv6 on Wi-Fi, but not on cellular, because the modem manufacturers have not supported IPv6, and that's another gotcha. So basically, if you think, this is sort of just re-summarizing, but you can see all of those places on the mobile phone, you need to have IPv6. One of the good things, though, is we do see a lot of rate of change in terms of mobile phones. People replace mobile phones every year to 2 years. The rate of change of people's desktops or CPE equipment is not so often, is not refreshed so frequently. I don't know how many people have updated their modem or their Wi-Fi access point at home in the last 2 years. A lot of that stuff does not get updated quite often, or if people have a set-top box, those don't tend to get updated as frequently. So mobile phones will be regenerated quite frequently and get updated, so that's going to help a lot. So one of the things that we have seen is that we have a lot of the major modem manufacturers that's happening in silicon. They're starting to address this, but not everybody is, and it's also a cost race. So we're seeing new entrances, new vendors coming in the marketplace who are doing really cheap modems, and obviously they're doing the minimal set of the features that they have to, so IPv6 gets sort of left out. Obviously, the mobile OS. There's a lot of mobile OSs right now that are slowly supporting IPv6. A lot of them have some kind of support that's turned off because one of the things, like if you're following, let's say Apple, you know that they found a major power bug in iOS 5, and that's software related that they're trying to fix. Android is continuously trying to do new upgrades to their OS. And generally, once you get something out in the field, the ability to sort of troubleshoot and modify things on a mobile phone is very limited. So there's a lot of sort of pressure from any company and any operator's care unit to say, hey, let's have as few moving parts as possible, because if something breaks, we're going to have to support it, and it's hard to support. Usually mobile phone support, you put it in a box, or you go to the store and you say, here, they give you a replacement, and they try to figure out what's wrong. It's not really possible to troubleshoot a broken IP connection over the phone from your mobile phone. So there's a lot of resistance to have IPv6 on. Also, there's an issue about how to do IPv6 addressing and activation. I'll talk about that in a moment. That has to do with some of the peculiarities of how mobile networks are defined, but as I mentioned, the cellular connections are kind of like dial-up. And at least for IPv6, 3GPP has specified that the devices get a /64, and they have a sort of interesting address auto configuration where the MAC address doesn't come from the phone, but it actually comes from the network. The network specifies what the sort of link local address for the device is, and then uses stateless auto configuration based upon that. So getting that defined, getting that set up, and having that configured on the device is a bit challenging. So a lot of carriers are still looking at how can they deploy that effectively. Then, like I mentioned, the development language, POSIX sockets, Qt, Java, OS X, and what are all the APIs that they offer to developers. You have a lot of different development kits and different development languages in the mobile device space, so that's challenging. Then the apps, the browsers, the voice over IP services, the Facebook apps, the Twitter apps, et cetera. There's a lot of things that have to be addressed, and I don't think a lot of application providers, especially in the mobile space, are really thinking about how to do this. So again, there's a lot of complication. And at the end of the day, it's a business question. Can we generate more revenue by turning IPv6 on? Right now, the answer is probably not. I think it's more of a question of when will IPv4 start to cost us more money? And I'll talk about that. So in terms of IPv6 on phones, this is a bit challenging to find out. People are not really public about it, but as far as I've been able to figure out, there have been a couple of Android devices that have offered IPv6 on cellular, and I think that was mostly for CDMA networks for Verizon LTE networks. Verizon is very bullish. They want to go IPv6 for LTE, and they want to do voice over LTE. They see a big bet with LTE, and I think they want to sort of start to ramp down their CDMA network, because LTE and CDMA basically are two separate networks for them. So there's been a couple of devices. I've actually played with some at different events, but I don't know if they've come to market. I don't have an LTE device right now, so I haven't been able to check. But Android does V6 over Wi-Fi right now. And I think gogoNET has an app that does some kind of IPv6 on Android. At least I've seen it, but I'm not sure the details. So if you guys know, tell me. iPhone 4 just does IPv6 over Wi-Fi, not over cellular. Windows Phone right now is just doing IPv4. IPv6 is set to come in the next release, which is the Apollo, which is the sort of Windows 8, where Windows 8 is both covering both the desktop and also the mobile OS. Inside of Nokia, we've, since about 2003, supported IPv6 on Symbian phones, and that's been something that's been trialed quite heavily at T-Mobile here in the US. And actually, there's been about a trial running for about a year, so if you have a Symbian phone with T-Mobile, you can join the beta for free, and they give you specialized configuration for that. One of the challenges, though, that we have been having on Symbian is that the RFCs revised. We took a very, very long time to have DHCP-v6 specified. I think it took like 25 revisions in the ITF to get that spec finally approved. And things are always a little bit changing, different ideas about how do we support privacy addresses, et cetera. So maintaining the IPv6 stack is always a challenge. The Nokia N9, which I've been a product manager for, we just also announced a full dual stack add-on for that, so it runs both over cellular and Wi-Fi. For the previous product I worked on, which was Nokia N900, we also did a dual stack mobile IPv6 implementation as well as the NAT 4.6 app with Google. So we used that for a lot of trialing and playing around with. But that was mostly non-commercial. And there's a couple of, mobile dongles that do IPv6 over the cellular link as well. There's a Samsung and a Nokia. But it's not that extensive. From what I understand, a lot more stacks exist. They're just not activated or not put into productization. And that's also because a lot of the carriers are sort of lukewarm about actually deploying it and getting the infrastructure up in their production networks to actually run things. But from a high level, some of the requirements that we do get from carriers is that dual stack with a single PDP context, so IPv6 v4 on the cellular interface is the most common solution that the majority of carriers are asking. Some networks are wanting to support dual stack with parallel PDP contexts. So essentially your phone creates two, let's say, dial-up sessions, one which is v4 only and one is v6 only, and generally then the applications have to have logic to decide, do I want to activate v6 or do I want to activate v4? A couple vendors or a couple operators have been asking for v6 only, and they want to do all the translation in the network. And they actually see that as a way to sort of provide a nice quasi-walled garden for some of their services, or at least provide services within their network, which would be v6 only. There's a lot of things which they're looking at in terms of PNAT, DSL, dual stack light, dual stack mobile IPv6, and so on, so that there's 6RD. So there's a lot of these things which are in the trialing and sort of investigation stage. But some of this just points out that there's not yet a lot of consensus in the mobile space on what is the best way to start to deploy IPv6 at the network side. The other thing is that when carriers also have to figure out how do they provision the devices. So when you buy the new device at the store and you activate it, how do they configure IPv6 on the device? How do they know that the device supports IPv6? When you go roaming outside of the network, if you go to Europe, how do you know that this, if you're roaming in Europe and you connect to Vodafone, how do you know if Vodafone has IPv6 enabled or not? There's a lot of different scenarios, especially roaming, where things get really tricky. So provisioning and knowing how the devices should connect to the network is something that's still quite open. And then also, how do you do failback? And how do you do failback in a way that gets to be not bothering the users too much? So basically, the classic scenario, you try to connect to Facebook over IPv6, but IPv6 is not supported in your roaming network, so it fails. So after about 2 or 3 minutes, you get nothing on Facebook, and you do a failover to v4, and then it works. Most users are not going to be happy with large delays and lag times. So that's something that the carriers are trying to work out how best to handle that from a provisioning and knowledge side. In terms of the mobile network, I've been involved in trials since about 2003. We know a couple commercial deployments in 2010. T-Mobile is a good example. They've been doing trials all last year, public beta with off-the-shelf devices. So that's been working pretty well. We're seeing more and more this year. Verizon has been very public here in the US. And we're going to be seeing more next year, especially as more LTE networks roll out, and especially as carriers realize they can't get much more IPv4 addresses. There are a couple of gotchas, though, that really, this is the area where we need to start thinking about, outside of just the general end-to-end deployment, there are some specific issues that come up. So DNS server address discovery has been a really contentious issue in the IETF. And there's not really a good consensus on how to do this. So generally, in 3GPP, current situation is that when you create a cellular connection, the network will tell you what DNS address to use. Stateless DHCPv6 might be optionally supported, but not a lot of carriers are specifying DHCPv6, so an end terminal can't depend upon it. And then some people in the ITF have been pushing to supporting that in router advertisements. But right now, I don't know of any networks supporting router advertisements for the DNS server addresses, at least in cellular. In Wi-Fi, that may work. That's generally an ordered list of what you would need to do on the cellular interface. On a Wi-Fi interface, generally DHCPv6 is much more common. So generally, the mobile phone is going to have to say, okay, you're connecting over cellular, get the DNS address from the server in the cellular network. Now I'm switching to Wi-Fi. Okay, run DHCPv6. And our router advertisement-based approach is becoming more common. And since that is being supported in the router advertisement daemon in Linux and some other OSs, that probably will come more and more common. But then also the mobile phones have to support that. And that's been something that we've been looking at. At what point do we also support it? Because there's no point in adding extra code to mobile phones right yet. And right now, if you're using dual stack on a mobile phone, maybe for the present time, talking over v4 to DNS might be the quickest and dirtiest way to handle that. But generally, my recommendation is the more we can do over v6, and the more that's available with v6, the better it will be. Also, generally, how do you query DNS? If you query DNS with v6 or v4 in the wrong way, or if you induce certain, well, that will induce certain delays. So if you try over v6 first and you don't get a response, then you try over v4, you're going to have a lag on your mobile phone. And for some reason, I think everybody is much less patient with a mobile phone than on your laptop. On your laptop, you expect things to be delayed. But if you can have a 30-second delay on your laptop and you grumble, but you live with it. If you have like a 3-second delay on your mobile phone, you're annoyed. So there's a lot of questions, or there's still a lot of things to work through on what is going to be the best way to do some of the querying. So generally, querying A and quad A records sequentially works pretty well. Another alternative to do would be quad A, then A in parallel. That generates a little bit more traffic and have to have some extra logic on how to figure out when you get the response, what records to be respecting. But we're seeing a trend to support the points 2 and 3 doing querying the A record and quad A record sequentially or doing them in parallel. Which kind of brings up to one of the topics that's becoming more interesting in the ITF. I don't know if anybody has heard about happy eyeballs, but this is basically you want to have happy eyeballs. When people are using their phone, you want them to be happy. You don't want them to be delayed. So what are some of the things which we can do, especially at the application layer, to make eyeballs happy? Part of that would be to put more and more application logic to do things either sequentially or in parallel. So open up an IPv6 connection and try something over IPv6. At the same time, do it over IPv4. And have logic in the application or of the device to understand if you find v6 broken, then use v4. And if you've done them sequentially or nearly sequentially, you'll have a little bit of a delay, but then remembering what way you contacted your server or application or service will make things better. And then just knowing when to refresh and retry v6. If you do it, for example, after you change your interface or change to Wi-Fi and you come back to cellular, rerun v6 to see if it was a temporary solution or not. But a lot of applications can take a lot more logic into managing their connectivity. And essentially, a lot of mobile devices need to do that anyway, or not just mobile devices, mobile apps. Very, very many early mobile apps just assumed you had a pipe and the pipe wouldn't be broken. But we all know that when you go through a tunnel or go into an elevator, you lose the network, you lose your cellular network, and then when you come back up, the applications kind of need to know, oh, let me go recheck or let me rebuild the connection in case the connection timed out. I remember a couple of applications, like there was a very early instant messaging application, which had a 15-minute timer on it. So anytime you were on a phone for more than 15 minutes and your data connection was cut, the IM client would disconnect and never reconnect. So you hang up the phone, and then you wonder why none of your friends are chatting with you. It's because you've got a broken connection. So generally, if we're talking about this sort of happy eyeballs scenario, you have to understand we're talking wireless, and you're talking about small devices with small antennas that lose connectivity frequently. So you're going to need to retest your connectivity and rerun things quite often. So if that can be handled either at sort of a middleware on the device or at the application, I think that makes a lot of sense. I do know that most of the major browsers are building the happy eyeballs algorithms into them, so that will work on desktop, but also more and more also onto mobile phones. So that should bring better experience for end users when they're using a dual stack. The other thing, which is also a big gotcha right now, which I think is still not really solved in terms of the deployment, is tethering. So a lot of people might be using their mobile phone as a tethering mechanism. So you're talking to your phone over Wi-Fi from your PC and talking to your cellular network. Over V4, basically you're running a NAT on the mobile phone, and you're having a NATed phone for your dial-up connection back to the network. With V6, I don't think you want to run a NAT on your phone with a V6 connection. That just is stupid. That like is that's not really sensible. So some of the specifications are going to do prefix delegation on a mobile phone. So if you're getting a /64 on your mobile phone, you can do prefix delegation. Not all the carriers are really happy about that, and they're trying to sort through it. And actually, too, because carriers are trying to figure out how to monetize it. A lot of carriers do really wacky things about tethering to make sure that you get a subscription to it. I mean, I'm not going to tell you all right now. I'm happy to over a beer or whatnot, but they do really wacky things to try to make sure that you have a tethering plan. So, but for most people as users, you want to be connected. You want to be able to share your connection. You're paying for it, so why can't you use it? But there are really no good specifications on this, at least in the mobile domain. So some of this is kind of specifying with how do you do bridging with neighbor discovery proxy, or doing DHCP-v6 with prefix delegation, and that's in 3GPP release 10, but that's really not been deployed yet, and that's something that needs more implementation and more trialing. Then sort of the last big thing, which is also sort of open, is a lot of carriers want to do Wi-Fi offloading. So how do you maintain connectivity when you change interfaces from cellular to Wi-Fi and back and forth? The way that the carriers have defined the networks, these networks are completely different network segments. Quite often they're actually run in the carrier itself by different organizations. Wi-Fi is generally tended to be run by the broadband part of a mobile network, or by a carrier, and then the mobile runs the mobile network. So they're running different servers, have different addressing schemes, so that there's a lot of things in terms of how do you actually get this to be deployed, and how do you handle the addressing rules, how do you handle the provisioning, and how do you handle the management, and how do you handle the session continuity. That's also an open issue that we're seeing that needs some practical solutions. So Sort of just in terms of summary, basically, I think from everything that you guys have been hearing from yesterday and today and the day before, the networks are ready. A lot of support is already built into the network. In most cases, you can get IPv6 addresses, on your laptop and PCs with various tunneling mechanisms and even more and more native IPv6 connectivity, and that's getting more baked in the networks. We've been doing a lot of trials and starting to understand a lot of the gotchas, but we haven't in the mobile networks moved to actually running towards a lot of live networks. There's a couple net operators that have live IPv6 networks where things basically work. With T-Mobile, I basically didn't have any major things not working with IPv6 when I have that enabled. So we're getting really close into being able to get things live. But in terms of trialing, it would be good to get a handset that supports IPv6 both on cellular and Wi-Fi so that you can actually test that things work and work with the carriers who do have a IPv6 in their network. There's a couple of them right now, so you're even able to get that up and running. I would say also a really strong recommendation is pick a kind of service that would be good to run over IPv6, that would be beneficial, something that's going to be like live or real time or needing an always-on connection. And go with just trying to get one app working well over IPv6 and then build out from there. Make sure that the developers who you work with who make apps understand that there is something called IPv6. One of the things that you probably have seen is that there's been a huge gold rush in terms of mobile apps. People making, games, making all sorts of things for mobile phones. A lot of those people actually don't even know what IPv6 is. I've gone and talked to students at Stanford, and they've never even heard of IPv6 before. It's like people who are on Facebook or making Facebook apps even, they don't know that there's IPv6. So that they may be making assumptions that will make things not work over v6. Understand that address assignments are handled differently over different interfaces and sort of build in some connectivity logic in your app. Make your app realize that it wants to be connected and test the connections and manage connections. Don't make assumptions that if you have an IP address 10 minutes ago, you have a connection. You may not. You need to be able to manage network connectivity and sort of almost think that the device is actually having nomadic connectivity, that the interfaces come up and go down. And in that way, look at Happy Eyeballs. That's an IETF draft. I think I'll put some of these drafts and some of these references into my abstracts from the conference so that you guys can go and read a little bit more about it. But that's going to be a very important thing, that your app has to manage connectivity a little bit more and not just think that the phone takes care of the connectivity on its own. But at the end of the day, there's going to be big upsides to doing this, because obviously with a phone is only good if it's connected and has battery life. IPv4 really does negatively impact battery life, and if you handle the connectivity wrong, and IPv4 connectivity you have to assume has some amount of brokenness, especially through middle boxes, it will only get worse before it gets better. The carriers are going to have to deploy a lot of expensive boxes to maintain connectivity. Carrier-grade NATs for 5.3 billion users sounds like a lot of things to be managing, and if they want to go to have voice over IP and have that work effectively, that's going to be very hard to do with any private address devices. So essentially there's going to be very good upsides, but right now I can't give you a magic bullet to say this is how you make money with v6, but I'll tell you how you can lose money with v4. And with that, I guess we're done. Not tremendously late, it's 5:17. Thanks a lot for staying. If you guys have any questions, let me know or talk to me after.